Welcome. The topic is electrical system of a nuclear power plant. The plant electrical system can have different arrangements of sources, transformer, buses, depends upon its specific designs and the functional needs of the plant. The electrical system of a power plant is designed to provide diversity of reliable power sources which are physically and electrically isolated so that any single failure occurred in any of the sources will not be propagated to another source. In general, the plant electrical system consists of main power system and the auxiliary power system. The main power system consists of the main generator and its associated control to transmit the power to the offsite grid. And the auxiliary power system consists of two types. One is from the offsite grid through the unit auxiliary transformer, and this source is called the unit auxiliary power. And the other is through the reserve auxiliary transformer is called the reserve auxiliary power. Depends on the configuration and purpose of this power. It is designed with the redundancy to ensure the continuous operation even in the event of a failure in part of the system. The two sources of auxiliary power should be independent and electrically isolated. The system power is transferred to the plant distribution bus voltages by means of one or more transformers. Based on the power supply system requirement, we have normal power supply for the non-safety related drives and emergency power supply for the safety related drives. And we have uninterrupted power supply using for instrumentation and control systems and control voltage for the electrical distribution boards. Let me show you basic SLD of the power system. This diagram represents a simplified view of a power system showing the key components and the interconnections. In this, we can see the flow of electrical power from the generation source to the distribution points. The key components are offsite grids, main generator, main transformer, auxiliary transformer, and emergency DG are shown in this. Various voltage systems used in a power plant categorized by their voltage levels and applications. High voltage system of 400 kV of the main grid, 110 kV of the standby grid. Medium voltage of 10 kV is using for the motors which has higher power. Example as reactor coolant pump, condensate pump, feed water pump, and component cooling pump, etc. Further, we have low voltage systems with 690 volt, 400 volt, 230 volt using for the motors which has lesser power. AC uninterrupted voltage of 400 volt is using for the valve actuators, and the DC voltage of 220 volt is using for control voltage, and 24 volt is using for the instrumentation control system. Let me explain the different operational states of the power plant, focusing on the flow of power. The power flow is represented here in the red color. While starting and shutdown, offset power is using for the plant operation. This SLD represents the normal operating condition of the plant. The generator is feeding the power to the offset grid and using the same power for the plant operation. When the non-availability of the both main offsite grid power supply and the generator power supply, the plant is working with the other standby offsite power supply which fed through the reserve auxiliary transformer. Combining all, we are achieving the challenges of ensuring uninterrupted power supply to the safety critical systems, maintaining synchronization of the grid while ensuring the plant stability, managing the high voltage and current levels involving in the power generation and distribution. Thank you.